Hey guys, Mr. Inyart here. This is grade 6, module 4, lesson 32, and this is just exercises, not the problem set, but this is what's going to teach you how to do the graph and how to set up the table to make sure the graph making is easy if you need that before trying the problem sets. So feel free to watch and learn about lesson 32. The problem set video will be a separate video for time's sake. All right, let's get to it. All right, so grade 6, module 4, lesson 32. This is going to take what we've been doing with equations and tables, and now we're going to be graphing them. And so we'll talk about how to do that in depth before we get to the problem set. So remember to try and think about these on your own first, and especially the problem set, do the work after we go over the first couple examples, and then try to check with this if you need to. So here we see that Zin is buying beverages, and there's 8 per pack. So we have a table of number of packages per number of beverages, and so it's actually beverages per package. So there's 8 beverages per package. You can see that here. And so our rule across the table is times 8, and our rule going left is divided by 8. And so we can use the equation that the number of beverages is going to equal 8 times the number of packages, because for each package there is 8 beverages. And so if we're going to depend on the independent variable and dependent variables, remember the dependent variable is the one that you're usually on the alone side of the equal sign, okay, the T here. The one that is dependent upon how many packages you buy. Right? Every time I buy a package, my total beverages changes. And so our output, or the outcome, is our total number of beverages. So that is our dependent variable. All right, the dependent variable is the outcome, right? Outcome or output. Now the input starts with in, independent starts with in. The independent variable is the one that kind of drives the whole question, makes the whole thing happen. So the number of packages is what we use to find the number of beverages. It is an independent variable. It is the input that you put into the equation right here to get out the number of beverages. And so because it drives the whole thing, and it's what we're putting in, and it stands as a unique thing in its own, it is the independent variable. So the independent variable is usually what you're multiplying by something, or dividing by something, or adding with something. The dependent variable is usually what you get out of it, the answer. All right, so because it depends on the other side of the equation. So let's take this information that we put on here in our table of how many beverages we'd get based on how many packages we get, and let's put it in a graph. Okay, so you'll notice the graph is already set up in a way that we have kind of a left side and a right side, a first and a second. Okay, the first side here we're going to call X, and the other side we're going to call Y. And the reason we're going to do that is because graphs are made with an X and a Y axis. And so your independent variable is usually going to be the first part. All right, this is just a good standard. Your independent variable is going to be the first part of your table, because we work left to right anyway. So we're going to do whatever we need to do with our independent variable, times 8 in this case, and we're going to get out our dependent variable. And so looking at it left to right, we usually just make our independent variable our X line in our coordinate grid or in our graph. And the second part, the dependent variable, becomes our Y. And if you look down at the graph, all right, you can see that my X line, the horizontal line, I said was packages, which is our independent variable. And then I can just do that 1, 2, 3, 4, 5, 6. And you can see I wrote the word packages because you want to label your graph. And then my Y line, my Y axis, is my beverages, total beverages, my dependent variable, my dependent variable, and that is 8, 16, 24, 32, 40, 48, so on and so forth. And this one was pretty simple because, you know, the lines are all evenly broken up, so I can do my X lines by 1, I can do my Y's by 8, but sometimes it doesn't work out so smoothly. However, what we always want to do to make sure our graph looks right, the line looks right, or not aligned, it might be all over the place, that our numbers are evenly distributed. See these lines? These lines are evenly distributed. So I can't make this one worth 5 and this one worth 10 and this one worth 30 and then this one worth 32. They'd have to be evenly distributed. So I'm going to go by 8s. Every single one is 8 apart. And those are my beverages, and then I gave it a title, Beverages Bought by Zinn. So let's look at a couple more examples. So for example 2, we have a certain number of miles and in however many hours that takes. Well, again, hours is down here on X, and it's going by ones, right? So I'm going to say that this is my independent variable because this is what's going to drive the equation, which I actually wrote down here, that my miles equals 50 times whatever my hours are. And I got that by looking at my 1 hour and going here to 50 miles and saying, okay, 1 hour equals 50 miles. And so I can then say that 2 is at 100 and 3 is at 150. So for every hour, I'm multiplying it by 50 to get my miles. So my miles is my dependent variable because it's the outcome of multiplying 50 times my hours. The independent variable are my hours. And so the hours are X, independent is X, and the dependent variable is miles. They labeled it road trip, so you can see this graph has everything it needs, labels, numbers, and then the only thing they didn't do was connect their dots, which you don't always have to do, but I like to because it looks good. In exercise number 1 here, Quentin's earning 30 bucks, right? Every time that, let's see, what's he doing here? Each week he earns 30 bucks. Okay, so we want to do weeks 1 to 8 and how much money he makes. All right, so the left side is my X. You can see I color-coded it. I could label it as well. The independent variable is going to be my X, and the dependent variable, the outcome of what I get, is going to be my Y. So this right here, right, this is what I'm getting out of the whole situation. After I multiply my weeks times 30, which I got from the problem. And so that is dependent upon the weeks. The weeks is the input and is my independent variable. So I named it Quentin's Money Saved, and I labeled my weeks and my money. And then I wrote my 0 through 6 on this. As far as I couldn't get to 8 because there's only 1, 2, 3, 4, 5, 6 lines. And then I did 30 through 180. Now, if I really wanted to get all this on there, could I do this as 2, 4, 6, 8, 10, 12? And then do this as, we can make this one 60, 120, 180, 240, so on and so forth. And then halfway would be 30. And halfway would be 1, so this would be 1 and 30. I could get them all on here, but you can see the line helps me project where I would go if I got beyond 6 weeks or beyond $180. And it lets me see the relationship. For every week, there's $30 made. 2 weeks times 30 is 60. So in this example, Zoe's collecting books to donate, and she's starting with 3 books. And this is important because in the equation, no matter how many weeks, even if it's 0, she gets to start with 3. So you'll notice that our independent variable, which is our weeks, what we're inputting into the equation in order to get out our dependent variable, which depends on the independent variable, that we're going to multiply the number of weeks but then add 3. So even at 0 weeks, which is 2 times 0 is 0, we're going to add the 3. She has 3 books, right? Because she starts with 3 books. Does that make sense? At 1 week, we do 1 times 2, which is 2, plus the 3, and we get 5. 2 weeks is 2 times 2, which is 4, plus 3. We get 7, so on and so forth. So again, my independent variable is my X axis. I labeled it weeks. My dependent variable is my Y axis. I labeled it books. And my title is Zoe's Books. And so you'll see this one does not start at 0, 0. This one starts at 0, 3. And then it goes up, and I divided these by 2's because I can't just put this one as 3. I know a lot of us will want to say, okay, let's make this one 3, then this 5, and then 7. But that doesn't make sense because these 2 boxes are the same distance apart, Yet 0 to 3 is 3 units, and 3 to 5 is only 2 units. So you're giving the same distance a different value, and that doesn't make sense. So you always have to find a way to evenly distribute your numbers, even if that means you go on your, halfway mark. That halfway is still there. Obviously, this is 3 because it's between 2 and 4. This is 5 because it's between 4 and 6. This is 7, so on and so forth. And so you can see that my line I draw is not going to go through 0, 0, and that is okay because we have this plus 3. That throws the whole thing off of the 0, 0 origin. And so let's look at our last one for this video. And so Eliana goes to the fair, and it's $5 just to get in. So no matter what, even if she doesn't ride anything, she's going to pay $5 to get in and say hi to her friends. And then it's an additional $3 per ride. So our equation is going to look like this. Her total cost is going to be the $5 original cost. All right, that's added to $3 per ride. So times R. So our independent variable is the rides, right? That's what we're going to input into the equation in order to get out our dependent variable or our answer. And that's our total cost. So even if she doesn't ride anything, she spends $5. But if she rides one ride, 1 times 3 is 3, plus 5 is 8. If she rides 2 rides, 3 times 2 is 6. 6 plus 5 is 11. And so we make this graph, Eliana's Fairground Money. Over here, down here, we have, you'll notice I'm missing some things. So let's fill those in. Rides goes down here. I need to have my labels. And on the other side is I'm just going to put a $sign for total cost. And now we can say our graph is complete with all of my marks plotted. So 1 to 8, 1 to 8, 2 to 11, 2 to 11. So another reason we always like our independent variable first and our dependent variable second, our x and then our y, is because this tells us our horizontal and this tells us our up and down the same way we read an ordered pair. Later on, you're going to find that we're going to take these and we're going to rewrite them as ordered pairs, right? Isn't that really what I did here? This is going to be 5 to 20. This is going to be 4 and 17. Aren't those ordered pairs? And I can do that with all of these just like that if I always put my independent variable, my x, first, my dependent variable, my y, second.